So today I will share our work, which is called RAU, Interruptible Automatic Infection Diagnosis of COVID-19 Pneumonia with a Residual Tension Unit. So in this work, we propose a novel deep learning method for rapid and accurate segmentation of COVID-19 infection regions in chest CT scans. So our development model is based on the unit architecture, which is a well-known medical imaging segmentation framework. And we explored both the residual network and the tension mechanism to improve the efficiency of UNet. Moreover, we conduct the experiments on a publicly available CT image datasets, which collect from patients who are affected by the COVID-19 to assess the efficiency of the development model. And we also show the outstanding performance, demonstrates that our study provides a promising segmentation tools for timely and reliable quantification for low infections, especially for the COVID-19 diagnosis. And we hope this one can help provide the effective pipeline for precisely COVID-19 diagnosis and fast. Okay, so for methodology, so as we can see on the poster, there's like a very rough architecture, which we built based on UNet. So differently, we do not use ResNet. So we use a more advanced structure, it's called ResNext. And moreover, we also utilize attention mechanism to emphasize infection regions. So for more details about the methodologies, so please refer to our whole paper, which is available online publicly. So you can take a look and see how technically it be included. And besides, we also provide the highlights about the results and the visualizations. So first we go for the visualizations. So as we can see on the top right, so we provided two samples, which is like A and E, which is like the source CT image from patient who's suffering COVID-19, and as a B and F, which is ground truth, which is marked by radiologists about the infection areas, which is we call this ground truth because it's marked by the professional. And for C and G, which is learned by our model. So we can see it's pretty similar with ground truth, while D and H, which is like the image marked by the UNet. So we can find on H is barely nothing be marked on. And on the tables, which is our quantitative results about our model. So you can see we have two different settings, one which is like with data augmentation, and another one is no augmentation. So basically the augmentation is just like we manually flip the image by several times to produce different CT images to help model to converge. And for this work, we are expecting the outcome of quite a series of future works which we can see. So for example, in case of new disease such as coronavirus, the amount of ground truth data is usually limited, which gives us the difficulty of data organization and annotations. So in the future, we maybe can utilizing some modern or advanced deep learning method, which is specifically for such case, such as zero-join learning or future learning to relieve the problems that lack of the annotated CT images.